Well, it's official, folks. Looks like we can get started for today's work. Before we start jumping through the announcements and our current work today, any questions folks would like to start us out with today? Okay, well, for the announcements, I don't have too much, but I did want to mention quiz 3 is available today. And sometimes I might post it a day early, only because Thursdays happen to be my busiest day this week or during the work week. So if you see it available a day early and you want to do it, then I'd say give it a shot. There's always a possibility that some of the material on the quiz might be covered today. So if it looks a little bit foreign, you might want to wait a day before starting it. And the due date is going to be the normal time. We'll have it due Monday, even if it's posted a day early. So quiz 3 is ready to go. And pretty much what we're doing on quiz 3, we take a look, are the major things that you'll have to know how to get through when you're doing exam number 1, as far as the calculator is concerned. So going through this quiz here, it gives us some raw data to input into the calculator. And then very down the bottom, it asks for the sample mean. We're going to practice on working with that today, and the sample standard deviation. So if you can get through this quiz by punching everything into, say, your TID4 calculator, then you'll be in great shape for exam 1. Well, any questions, folks, about the quiz at the moment? I know it's a new quiz that we just threw on here. Okay, let's go back to the rest of the stuff on the announcements. So essentially, what's on the quiz, we're going to be practicing that today, calculating the sample mean X bar, the sample standard deviation S. If we finish this section a little bit early, we'll jump into 3.3, but I think we'll likely end our Thursday class on that section there, where we change to the median for the center and the IQR for the variability or spread, only because our distributions become very skewed in that section. So also, we're mentioning the exam a little bit. We are getting a little bit closer. If we scroll down a bit, I do have the exam materials all posted and ready to go. So exam number 1 is only going to involve these sections right here. Essentially the section we end on this week. The stuff that we do on this week here is going to be a normal week. I'm not going to put it on exam 1 since it's tough to learn, do your homework on, do your quiz on all that new material and just throw it on exam 1. And so this is kind of how the pattern is going to go for exams. Once we finish section 3.3, we'll have a week to absorb that material, look at review questions and study. And then that's where 3.3 is going to be as the last section on our upcoming exam. Does that make sense so far? Awesome. If you want to practice the exam, I posted two pieces of information here. The first one is just a link to a large PDF, and it's my attempt to give you essentially what's a test bank. I don't directly ask questions from here, but when I go to write an exam, I take a look at this document and see, are my questions at least similar to what I put here? These are also highly similar to the lecture notes, which were all based off WebAssign essentially. And so if you go through these, you'll know about what the questions would look like. You'll know how many parts and things like that. But this is not a real exam. It would be way, way too long. Essentially, I'm going to pick 4 or 5 questions, a representative sample from this document here, and that's going to be the exam 1. I'll change the questions, the context will change and things like that. But if you can solve these kinds of questions, then you're going to be in great shape. It is long. It's my attempt to tell you all the things that could be on the first exam. But as you go to the very bottom, that's where you're going to see the solutions. Those will be in green as well. So you could print this out if you like. I definitely use my student account for that. It's 26 pages. Or you could just use it digitally like here. So that's the first document. As you go through here, these are solutions written by me, and mistakes do happen. Sometimes I might miskey something. Sometimes I just made a mistake. So if you see something that looks odd, please never hesitate to email me. I'll take a look at it, work on it with you, and we'll revise as necessary. So that's the sample exam 1 that you see here. I also posted blank lecture notes. Well, there's 2 places you can find these. The reason I posted this is, for example, if you want to study section 2.2, you could open it up here. It has all the solutions, but you don't want to study a document that has the solutions. Our goal is to produce those solutions, so it's kind of a disservice to look at this as studying, unless you're checking your own work. What you could do is go all the way up to the top. These are the blank lecture notes in the Word file. But if you do prefer PDFs, that's what these are right here. They're just PDFs of all the blank lecture notes. You could say grab section 2.1 and think of this as really just a worksheet. You don't have to solve every one of these, but if there's another section you want to really focus on, this will be available for you as well. And I'll do this on an exam by exam basis. So those are the resources for our first and upcoming exam. I'll talk a little bit more about it once we get a little bit closer to the end of next week. But I guess those are the main things I wanted to say. Any questions or comments at the moment? Okay, well, one last thing, and we'll be through the announcements. Let me see if I can bring that back still. Sort of, well, it's always kind of hard to put it where it should go. Okay, last thing I did want to mention is, essentially each time I grade something, whether it's a quiz, or maybe say the end of the week, Thursday or Friday, I go take a look at your WebSign score. I'm only going to look at the score on things that have gone past due. So anything that's still upcoming, I'm not including your grade on that. But I take your WebSign score, I take your quiz scores, and they all get posted to Moodle. So the arrow here is a reminder. You can find your grades all the way over here. I would say it's always a good habit to take a look at that on a week-by-week basis, see how you're doing in the course, see if something's missing, because mistakes do happen, whether it's this class or another one of your classes. It's always good to be checking that kind of stuff out. And if you ever have questions on grades, please don't hesitate to ask. I'll be happy to help. And by the way, if you're wondering, how did I calculate the grades? This is essentially how I did it. I went to the syllabus. I noted, well, there's only homework, the web assign, and there's only quizzes. So I just took these two components and calculated your grade based off just those two. If you want to know the exact formula, just let me know. I'll be happy to share. Well, any last questions, folks, before we get started? Okay, so those are our announcements for the day. Nothing too major. We do have exam one coming up, but again, it's going to be Monday of this week here. So we still have some buffer time to study those topics and get fluent with that kind of material. But now for the moment, we're in section 3.2. And what we did in section 3.2 was took a look at the initial formulas for the sample mean X bar and the sample standard deviation S. So now let's jump back in and go from there. So we were mainly just talking about these formulas before we ended class, but today we're going to give them a real try. We're going to calculate by hand using these formulas. Then we'll see how it's going to go if we're going to do it more regularly, say like on WebAssign homework, quizzes, or exams. We'll start using the calculator more and more. But because these formulas are complicated and convoluted looking, it's good to practice this to see just how it all works, at least once by hand. And this is that example where we'll do it in. This might be a quiz problem, but I'm not going to ask this on an exam, because honestly, if I did, you have 50-minute classes, that's possibly 15 minutes already. It's pretty time consuming to do this. But first, let's give it a try. I have some random data. Here it is. No context, I just have 4 random numbers. What I want to do is calculate the sample mean, sample variance, and sample standard deviation. So let's give this a try. Let me zoom in just a bit. First thing it wants us to do is we walk through this table and we'll calculate each one of these in turn, or at least do the major work involved with that. First thing we have to do is put in the data value xi. And honestly, that's already confusing. Anyone happen to know what would go here based off that column? Let me show you where I would look in the notes, because again, this is a weird table. It's hard to get started, but once you get a feel for what goes where, it's not so bad. Let's go to the very top where it says notation. I'll just poke this here for just a moment. It says X is the variable of interest. N is the number of observations in the data set. By the way, we should probably fill that out right here and now. For this kind of problem, we should know exactly what N is. N is the number of observations, so I have 1, 2, 3, 4. So our sample size N must be 4 in this problem. That takes care of this. But now we want to know, what is X1, what is X2, what is Xn? These are just the observations in the data set. When you see Xi, it just means one of the 4 different observations. So down here, the first data value, really all I'm doing is taking these and dropping them into the table. So the first thing we have to do is pretty fast. 13, 15, 19, 21. So there's 3 columns, one's done. It's like we're a third of the way through it, sort of. But any questions, folks, so far? Okay, now that we've done that column, the next thing we can calculate really quickly is sample mean. Let's grab the formula just to see how would that formula actually work if we were doing this all by hand. So I'm going to zoom up here for a moment and grab that formula. So the sample mean says, in order to calculate it and get our X bar value, we have to sum all the observations in the sample. That's just these right here. The formula is saying take x1 plus x2 plus xn. Well, you're still doing the same exact thing, adding those up. And the sigma x is just saying, again, the same thing written in a redundant way, add up that entire column. So that's going to be the numerator. We definitely don't want to do everything by hand. That gets extremely tedious after a moment. So we'll add these up in the calculator. So I've got 13 plus 15 plus 19 plus 21, and our sum comes out to a value of 68 altogether. So let's drop that in. X bar happens to be 68, or excuse me, yes, 68. Kind of confused myself, sorry about that. And it has a denominator. Anyone see what the denominator should be? Exactly, we go to the number of observations in the sample, which is n, and for us, that's just going to be the sample size of 4. So now we drop that in, and we just about have it, folks. The sample mean is back in the calculator, take 68. But here's a nice little trick. You don't have to type 68 again. Just hit division immediately. Notice it says ANS. It's referring to the prior answer, which is referencing that 68. So divide 68 by 4, and you'll get the value of 17. So we did it, folks. The sample mean of this data set, whatever is going on with these numbers, we know at least we have a value of 17. And that means this one's done. That's kind of fun. That's essentially what we always mean by the sample mean, the arithmetic average. Just add things up, divide by sample size. So next we'll be doing deviations, sum of squared. That'll give us variance and standard deviation after we finish the next 2 columns. Any questions at all so far? Okay, so let me clear this out. The sample mean being 17 means 17 is just the most typical value, or the value that all the numbers are closest to in this data set. And now let's start working on variance. I'll just post the formula here for our reference. And the variance is saying, well, if you want a sample variance, the symbol for that is S squared. And look at what it tells us we need to do. We need to go to every observation. X1 would be the first observation, 13. Subtract the mean, which is 17, square the result of that, and then do it all over again with the second observation, X2, which is 15. Keep on doing that until you get to the final one, Xn. Take 21 minus 17 and square it. Then finally, that's your entire numerator. We'll divide by n minus 1 of the summation of everything to the left, and you'll get your variance after all of those operations. So actually, these last 2 columns, it's all just to calculate variance alone. But it's good to see how it goes, so let's try this out. First things first, I'm just going to do this in black. It wants deviations from the mean, xi minus x bar. That xi minus x bar is just each one of these components that we're going to be adding up eventually after we square them. So here I'll go, the xi is 13 minus the x bar, sample mean of 17. X1 will be 15 minus 17. Then 19 minus 17. And finally, 21 minus 17. So these are what we mean by deviations from the mean. Let's calculate these out. I'll get a -4, -2, a +2, And this should be a positive 4. If my arithmetic is not going sideways, that'll go right to everyone so far. Okay, now something happened in this column. And let me tell you, this is not a coincidence at all. When it comes to the deviations from the mean, this right here, let me add a different color, must add to 0 every time. There's no coincidence at all. And double checking it, -4 plus -2, we're up to -6, plus 2 plus 4, that's a +6. These deviations really do sum to 0. So it's nice to have a tiny little check baked in halfway. And I think this is a WebAssign question as well. When you see these, they'll show you a problem that has them in WebAssign, and they'll ask you, what should the values be? The sum of deviations always add to exactly 0. The only reason they might not is if that was rounded to some value and we didn't use the exact value, then this is just going to be extremely close to 0 after rounding. What we did, folks, we have the deviations from the mean, but this is all we calculated in this S-squared formula. The inner part of every one of those components, the inner part in the summation section there, we still have to square everything and add them up. So any questions at the moment? Okay, so this 2 you see on S-squared is really because of this 2 you see in the formula. Whether you're looking in the formula below or in the table, it's really the same formula we're going to be using. The reason we square everything is, once again, all the deviations add to 0. So without squaring it, we have no sense of how spread out the data is. If we force everything positive by squaring, we at least get some measure. So here on the right-hand side, we're going to square all values. Let me write out what it would look like. Then we can throw it to the well, if we need to, I'll show you in the calculator. These could be nasty in a different problem. But if you're going to square -4, I encourage you to write it like this. I mean, if you drop the parentheses, you may or may not be fine. But if you use your calculator and you drop your parentheses, you will not get the right value. It's really weird. And the reason for this is a negative number times a negative number, which is what the squaring is saying, has to result in positive. So this has to be 16. In fact, if you just ignored the negative signs right here, that's not a horrible strategy. It just is weird when you do the check where they add to 0. So I usually never drop the negative signs because of that reason. But just for extra intuition on this, take a look in the calculator. If you take a -4, raising it to the power 2, you could just use this button here as a shortcut. -4 squared gives you the wrong value. So always when it comes to squaring things, any even power, we always need to be extra careful on the calculator. Getting it in just right means you type a parenthesis first, -4, close that parenthesis, and then square it to get the true value we're expecting. So that's just a weird algebraic issue right in the middle of this problem. But let's keep on going through and finishing out the rest. The next one's going to be -2 times -2, resulting in a +4. Then on the next one, we're past all the trickery. We're just squaring positive numbers. So 2 squared, you really don't need a parenthesis for that unless you want one. This will result in a 4, and then finally 4 squared will result in 16. So we're just about done. We did the squaring portion of all of these. The only thing we haven't done so far is this portion, the summation, or if you're thinking of the expanded formula, we haven't done any of that yet. But they're all right here, so that's our next step. Add the sum of the squared deviations. So let's change to this color right here. Because we're so close, let's now say S squared is going to be equal to the sum of all these values. So I'll write this out just so it's on the notes. 16 plus 4 plus 4 plus 16. And now here's where it gets really awfully strange. Anyone know what the denominator should be? It's 3, absolutely. And that's always really, really weird about these kinds of problems. If the sample size is 4, observe when it comes to the variance and the standard deviation, we wouldn't divide by 4, you're going to divide by 1 less. So I'll put here 3 minus 1 just to start it off. But if you're working this out in the work, it might be safe to just put in a 3. I'm putting, oh, that's not quite right. I dropped it 1 too low. Let me try one more time. Let me put in the sample size of 4 that we started with, then minus 1. If you put in just a 3, then that's probably the better thing. But for the sake of notes, I'm writing it this way, not correct this time, only for the reminder that's always 1 less. So watch these denominators. That's another thing that's kind of tricky about this process. And even though we're going to be doing this primarily in the calculator, this is still something we watch out for the calculator as well. There are 2 formulas. We're using the one with n minus 1. Well, we just about have it, folks. We just need to add these together and divide by 3. Any questions so far? Okay, so back to the calculator. If you had some nastier stuff right here, here's a decent strategy for just throwing it all to the calculator and moving along to the next problem. Wrap the whole parenthesis around with, the whole numerator around with parentheses. So start with the open parenthesis here and just type it in left to right. 16 plus 4 plus 4 plus 16. Again, they're not bad numbers, but they can get bad. Now with the parenthesis closed, for the division bar here, just click on divide. And for my denominator, well, if you didn't simplify 4 minus 1, that needs parentheses too. So without doing any simplification, just throwing it into the calculator, this is honestly just more practicing with the calculator. Here's the value I get, 13.3 repeating. Any questions so far, folks? Okay, so now we have the variance of the data set. It's a way to tell how spread out the data is, but for us, the variance is going to be just an intermediate step before we get to the real thing we want, which is standard deviation. But first, let's carry down a result. I believe they said round intermediate, sorry, that's a hard word to read, computations to 3 decimal places. And this is what we mean by an intermediate computation. We don't have the standard deviation yet, so I'm going to give this a 13.333. Well, we're almost done, folks. Any questions at all in obtaining the variance? Okay, let me bring in our next star for the show here, our formula for the standard deviation. It turns out, yeah, the formula looks really, really awful because they gave us the whole thing. But if we focus on the pertinent parts that really matters to us here and now, it would be this. The sample standard deviation, which we refer to as just the letter S, is equal to the square root of whatever your variance happened to be, which we call S squared. So that's kind of nice in a way. Once you have variance, the sample standard deviation S is just obtained by square rooting it. So we're essentially done with that formula. Let's input our results and get our standard deviation. S is going to be equal to the square root of 13.333. I'll use that intermediate rounded value. They ask us to round our final answer to 1 decimal place. So once I get here, we'll make that rounding happen. So back to the calculator. If you need to square root something, which you may have to do occasionally in this class, it's right here under the x squared button. Let me see if I can make that any bigger. But it's printed in blue. And so the trick of the calculator is, if you want anything blue, or if your calculator is a different color, hit the second key, type this button right here, and it'll print in a square root symbol. Now from here, you could just type in 13.333. That's always a fine strategy. But sometimes we need to use some nastier numbers. And this is a great strategy again. Hit second key right here, and now hit the negative sign to produce the prior answer. If I do that, I'm not actually putting in 13.333. I'm putting in the true value, 13.3 repeating. This is the most accuracy you could ever really get in the calculator. And this is what I'm going to get as our result for this. 3.65. Or if we're rounding to one decimal place, this would round up to a 3.7. So I'll say here, finally, after all that work, S is equal to approximately 3.7. I put an approximation symbol here since sometimes that's my habit, but if you don't put those on, I'm not too worried about that at all. I'll always assume you did approximate. In fact, I forgot to do it right here. I did approximate on that one for variance. So we've done it, folks. The sample standard deviation is in purple, the variance is in green, and the sample mean is in blue. Now, let me remind one thing that's kind of tricky about this is when we go to do this, we have to say what's what. I had to use X bar here, S squared and S to say what is what when we go to solve these. But keep in mind, another thing you need to remember is if I say sample mean, you have to know which symbol of that is, what that formula is, or the intuition behind it. If you say sample variance or sample standard deviation, you have to know which one each one of these are as well. But I guess we did it, folks. That's our initial problem. Any questions at all in getting through this one here? Okay, our main goal is really to just practice understanding the formulas and then practice how to do this really, really fast. I can't really ask you to do this same kind of process even on the quiz. In fact, on quiz 3, it's not hard to get the sample mean, but getting the variance is really, really hard on that quiz. That could be the better part of an afternoon, a couple hours just to make sure you're slightly accurate on all that. So we're going to practice using the calculator on these notes for the next problems. And how about just as a warm-up, let's see how close we were on 3.7. Let's practice it right on this problem. Does that sound all right to folks? Okay, so this was really just to help us understand the formulas. Now let's see what the calculator says about our work. First key we must hit is stat key here. Hit enter right away. And that's always annoying, but keep in mind you can go up, hit clear. Now, I accidentally did this once. Don't hit the delete key. It works. You will delete L1. It's not like it's gone forever. You can bring it back, but that's not something you want to have to deal with. If that did happen on exam, I would help you on your calculator to bring back L1. But for the rest of these kinds of computations, the exam itself is that using the calculator is part of the exam itself. So here, let's go use the clear button, then hit enter to wipe out L1. Type in the data. Let's see, it's just those 4 observations. That's kind of nice. 13, 15, 19, and 21. Then once your data is in and we're satisfied with it, it's the stat key again. Then right arrow to calculate. And then pretty much from here, I just jam my enter button in all honesty. If you hit enter, you're going to go right to what you need to go, one variable stats. I never change anything here, so I just continue to hit enter until it prints all of this out right here. So let's take a look. The sample mean X bar should be exactly 17. We didn't have to round. And hey, we got it. It's not going to give us our variance on this list, but it will give us our standard deviation, SX. And if we rounded SX to one decimal place, you know what that actually agrees? It would be 3.7. Our work did not give us this much accuracy necessarily. Oh, actually it might have because we didn't round there. We used the prior answer. But that's how to get it all out in the calculator. And let's just do one more screenshot here. Just as a reminder that this value is S, the sample's standard deviation. And this value here is X bar. Well, I mean, that one's a little bit more obvious. This one's a little bit weird at sigma. And so if you're curious, what is that? We kind of hinted at it before. It's a population parameter or population characteristic. Sigma is the population standard. I'll use STD for standard and DEV for deviation. Whereas mu is the population mean. So like we mentioned before, in calculating this X bar right here, what I can say is that mu, which is unknown, is approximately equal to what X bar would be. And sigma is also an unknown. Sigma is approximately equal to S. But we always have to be really careful because our data is almost always in this class assumed to be a sample. That means even though the calculator can calculate sigma, it's making the wrong assumption. And the reason the numbers are different is it will divide by n, not n minus 1, if they're using the sigma value, giving us the incorrect formula. Well, that's the rundown of this kind of formula. We're never going to use all of these formulas up here directly. That's extremely tedious, but it's good to know what they say and how they work. That way the calculator is not just some mysterious black box we throw numbers in and hopefully get the right numbers out. Well, any last questions, folks, on getting through this problem? Okay, let's try it out then on the very next exercise. So think of example 1 as the warm-up. Example down below is something a little bit more typical for what you might see on either a quiz, an exam problem, or even WebAssign. So now we have context. That's always nice. It says, although bats, so we're talking about bats, that's fun, are not known for their eyesight, they're able to locate prey, mainly insects, by emitting high-pitched sounds and listening for echoes. They call that echolocation. It's kind of an amazing above-ground sonar that they have. Next, it tells us a paper appearing in Animal Behavior, the echolocation of flying insect by bats. This is from 1960, but it's good data still. Gave the following distances in centimeters at which a bat first detected a nearby insect. Well, that means the context for these data are distances and centimeters. We have numeric data. This would be numeric continuous type data. And let's see what else is going on. We have a nice histogram. It's an odd looking one for certain. This kind of histogram, it doesn't necessarily have any main peak. Would you agree with that assessment? It's uniform, except for this one little blip that fell off to the right. So if your data looks flat like this is pretty unusual. This is the first one we've seen. This would be considered uniform data or uniform in shape. Again, it's usually odd. We typically see data peaking or accumulating somewhere, either in the middle or the left or the right, it's skewed, but not for these data. This is how they came out. Well, let's now get to the next portion of the problem. And to me, part A is the hardest question in example 2. It's something that we have to tackle over and over and again in this class. So it's something we'll practice quite a lot. In fact, we did this kind of stuff on the first day of class. So as you look through this context, here's the big hint that tells us what the population sample might be. They said a bat. That means there's just one lucky bat who's gorging on insects, and they're using that bat in an experiment over and over again. And that one bat generated these, 11 distances altogether. So we need to keep that in mind when we go to say the population. Does that make sense so far? Awesome. So here's what the population would be for this. The population is all distances at which this bat, I'm saying this bat just to emphasize, it was one bat used repeatedly, locates, they use the word detects, echolocates is the right word, I'll just say locates to shorten it up, locates an insect. So we're looking at all conceivable distances that could ever come up for this one bat in the experimental setting that they were looking in. Experiment's not the right word to use there. In this research setting that they're looking at for this study. And now if that's the population, any volunteers for what the sample ought to be on this one? Yeah, you're saying these values here? Exactly. It's the actual values that they came up with, the data that they outputted. It's not all distances that this bat could conceivably come up with in this research setting, but it is the ones that they did come up with. So we'll say the sample is the 11 distances recorded. So we've got it down. That's the population. That's the sample. Honestly, I think this problem is a little bit more tricky than normal, getting population and sample, only because of the way you might read this problem. For example, when I read through this problem, I assumed there was 11 bats, and these were just the distances they had to obtain to detect the insect. But no, it seems that they're talking about just one bat used more than one time, 11 times altogether. But now that we have that, we can get to the next most interesting part of this context. Here's why population and sample, it's a hard question, but it keeps on coming up repeatedly for us in this class. When we do statistics, we have to describe that thing there. I called it a parameter in these notes, but keep in mind the author also calls it population characteristic, which is a fine way to say it as well. We're going to do things that estimates that population characteristic, hypothesis test related to it. But if we can't say what it is, then we're in big, big trouble. So part B, it's not as hard if you know what the answer is in part A. But if we never thought about part A at all, I think this is extremely mysterious. It's really hard to nail down what exactly is mu. But here's how we can start. I'll just write mu equals, and when you go to write this, try to go say upwards and then just do a letter U. It has like a longer tail as you start. It doesn't have to be perfect. If it looks like the letter M, I'll assume it's a mu. Now it's our population characteristic. In fact, if we go up to the notes for a moment, we wrote it down once. It's the population mean of something. So let's go back down here. Mu equals the population mean of all distances at which this bat locates an insect. So that's what the parameter is, and that's what they want to come up with or estimate in the study. Now, they can't actually calculate mu directly. They would have to really leave that bat in the testing area for its entire life, getting more and more outputs. That's just not going to be a great life for this bat. It's not really something they could conceivably do, but it's something that they can still define and estimate. In fact, we take all these data here and calculate the right statistics, we have estimated mu. That's our main goal in inferential statistics. Estimate the unknown population characteristic right there. Well, any questions, folks, on writing down mu? Okay, I would say for the sake of, especially exam 1, which is coming, think of what we did right here as more of a preview. We will have this kind of issue in exam 1 where we have to describe a population and sample coming from chapter 1. But this is a preview because it's our main target of the course and stuff that comes up in chapters 8, 9, 10, and 12. Now we're ready to go. Well, there's a little bit more here. We'll describe the shape of the sample data and then calculate the statistics. I accidentally spilled the beans a little bit on this one, but let's still go back and run through what the shape would be of these particular data. We said when we looked at these, it's uniform data, right? It's flat. But my question to you is it symmetric though? Or at least roughly symmetric? I would agree with folks. I mean, the symmetry would be perfect if that was gone. If this was our data right here, absolutely perfect symmetry, which is pretty unusual. At least the symmetry is perfect as far as the histogram goes. The dot plot may be less symmetric. If it looks like this, there's a slight skew to the right, but still, if we fold the paper across a dashed line like this, most of those rectangles in the histogram overlap just fine. this is the only odd one out. So I would say for us, these data are, sure, they're uniform, but the bigger thing we want to know is symmetry versus skewing. So let's say symmetric. And uniform. This observation right here, again, we're going to have a rule of thumb to determine if it's an outlier or not. But if it's just one rectangle gap away from the main group of data, I wouldn't consider that to be an outlier at all. So we don't have to mention outliers with this. And if we say something is uniform, we also wouldn't say it's unimodal or bimodal or otherwise. Uniform means no real modes whatsoever. So this would be a complete description of the shape of the data. Main thing we wanted was this right here, symmetric, to allow us to pick the right statistics. Well, any questions, folks, on getting through the shape of these data? Okay, and one thing I need to do myself is definitely read the question. There's more to it. Now that we said what the shape is, we want to know what summary statistics best describe the center and variability. But if we're dealing with symmetric data, we always say for center, use X bar, which is the sample mean. And for variability, or how spread out it is, we will use S, the sample standard deviation. So that's what we'll be doing right next on part D. Any questions or comments so far? Okay, so on the next problem, it says, use your calculator to compute the sample mean and the sample standard deviation. And the wording here is kind of strange. When it says, use your calculator, you'll see that sometimes in WebAssign, sometimes on quizzes. And it's just a way to remind you that you're not meant to calculate something like the standard deviation S, especially by brute force. It's a horrible experience. And it's even tough with just 4 or 5 observations. So instead, we're going to go up here, grab these data, and just import them into the calculator. Well, let's give this a try then. If you have your calculator with you today, please give it a try along with the class. And if we're a little bit off, please let me know. We'll see if I missed a value. So first thing to do is hit stat, hit enter. And then you could just overwrite these, but best practice is go to where L1 is, hit the clear key, and enter to wipe it all out. Now, no issues of data being hidden somewhere in that list. Now, always in WebAssign, definitely you want to go methodical. And if you're trying this in WebAssign and you keep getting it wrong, you have 4 tries on each one of these kinds of problems. On your 4th and final try, especially, even if you used it even just a couple tries, definitely consider hit the Ask My Instructor button. If you can't find what the mistake is, it might be something as silly as just maybe rounding, or maybe some of the numbers were inputted a little bit incorrectly. So if that ever happens, don't hesitate to reach out, but let's give this a try. I'm going to go row-wise, top to bottom. Okay, I think I have them. I'll double check. There's 11 observations here. And so, yeah, it's asking for my 12, where it says L112. That means we've got it all in at least. I might have mistyped something. I wasn't double checking. And by the way, in WebAssign, I know how awful this sounds, but there is real time-saving value in WebAssign. It could save you an hour possibly in the entire semester. You just go back through these and just double check them again. Because again, it's horrible to accidentally put in a 32 instead of a 23 and lose the whole question when you know exactly what's going on. Well, with all the data put in, hit stat key, right arrow to calculate, and just jam your enter key. And we did it, folks. These are the values that I would get. Now, you don't have to put screenshots on your work if this was a quiz. I'm doing that only for the sake of notes. Well, let me do it one more time, just to emphasize which are the right values to pick. So the answer to this, oh geez, I'm on the wrong question. Let me try again. Scrolled a little too far. We're still on part D. So here's my output. We're done with that data. It wants to know what the sample mean is, the sample standard deviation. And I encourage you highly, when you're doing this on, say, a quiz or an exam, when it says sample mean, write out at X bar equals. We have to know which one is which if it's asking for two at once, especially. So that's the major reason there. Also, we need to just train our mind that we see X bar, think sample mean. And if you see a question that just says sample mean, you have to know we meant that symbol X bar. It comes out as 48 point, and I forget what we're rounding to. Let me double check. Oh no, did I forget to say? I must have forgotten to say, darn it. I'll have to make a revision here. Let's put it in right away. Round to 2 decimal places. So if we're doing 2 decimal places, we go to the 6 right there, the 3 to the right is less than 5. So this rounds down to 48.36. And that means we're just about there, folks. That's 1 down. Next, we want to get the sample standard deviation. The symbol for this will be S, and we use that value there, SX. On this one, my second decimal place is 8. Number to the right is 4, so it also would round down here to an 18.08. Well, any questions at all, folks, on getting those two values? I forgot to ask as well, are these values coming out the same for everyone in class? Are some getting slightly different? Let me check my numbers and see where I'm at on that. Again, that's kind of the worst experience about WebAssign. The numbers are not quite right, then we aren't going to get the right answer. WebAssign will know right away if even one value was changed. So just double checking, back into the calculator here, I'll hit the stat key. Oh, something weird happened. I don't want to be here. If you're in a menu you don't want to be in, hit second, and then the quit key. And okay, we're out of there. Let me try it again. Stat key. Now that's where I need to be. Hit enter, and let's see how close we are. I have a 62, 23, 27, 56. Okay, we got row 1 down. Then I have 52, 34, 52, 34, 42, 40, 42, 40. So far, so good. 68, 45, 83. 68, 45, 83. Okay, I think I have the numbers in. So let me try stat, calculate, jam the enter key. And those are the values I'm still getting there. Did that find the value that was missing or changed?
Yeah, the 40, I hit 4, I guess the 0.
Ah, gotcha, yeah. Those were the kinds of mistakes I make too on that. Yeah.
Thank you for those.
Yes, absolutely. Yes, absolutely. And again, this happens at WebAssign too. It's sometimes the most questions I get on the Ask My Teacher button is these kinds of matters here. So go slowly, methodically, and it won't be so bad. Well, last question of the day. They're asking us next. Well, we have these nice summary statistics. X bar is 48.36. That would go right to about the middle here. That looks about right. Standard deviation is 18.08. The last thing they ask us is, assuming that these sample data actually came from a simple random sample, give what will be referred to as a point estimate or the value of the unknown parameter mu. And we said what it was. It was the distances that one bat is going to locate his prey on average. We get to now say mu is approximately 48.36 centimeters, which came from the sample mean right up here. So in a certain sense, that is inferential statistics. We said something about a population of values using nothing but the sample data X bar. The sad thing about it is, unless we do the other half of the course, that estimate is worthless because I can't tell you just yet what the error is, the accuracy of that estimate. You want to know the hint on how we'll do that is this. Standard deviation will give us an idea of how accurate we can expect that to be down below. But I definitely ran over all my time there. Sorry about that, folks. Any last questions before we wrap it up? Okay, we'll have a terrific evening, folks. I'll see you all in Thursday's class. We'll be over into the next section.
Yeah, unit 6. I don't understand how to get to that. But if
Gotcha.
that one is there, but then I don't know how to put in like the list of numbers, if that makes sense.
It does, yeah. Let me see. So, second stat. And I think what you want to do is hit F2 for the edit.
Okay,
And then that's what brings in the numbers to you.
okay, perfect, thank you.
Yep, you bet. Yeah, that T86 is kind of an older model, but it should still work for this class.
Perfect, and then I'll just put in the numbers and go through the same motion as this.
I believe so. Actually, if you still have that screen pulled up, I can show you the next
Yeah,
steps.
for sure.
Let's suppose we just had like 7, 8, 9.
Uh-huh.
Now to do everything else, go second step. We want to go to calculate, which is that first option. So F1. Oh, no. Clear. Clear. Step. Jeez, wait.
Okay, I was like.
Yeah, there we go. Then I want to hit F1 for calculate. Oh, geez. Hang on. I think
I think
I'm
it
not too
restarted
sure.
it.
Yeah.
I need to turn on.
Clear. Second entry.
Yeah.
Oh, no.
I couldn't do that. I had to call my friend.
Oh, yeah, I was in the wrong menu.
It was edit. Okay, there you go.
That takes us to our data,
Yeah.
but then we have to go back to the strat menu. That's where I'm
Okay.
kind of making a mistake here.
Yeah. I
Okay.
spent 2 hours trying to.
Oh, second.
Would it be calculate?
Yeah, we want to go second. Yeah. I hit that. Calculate. I hit F1. I thought that's what we were. I'm not sure how to hit it actually.
Okay.
And then when we do one after that.
Doesn't seem like it's gonna work in that way.
Tomorrow.
Yeah, I'll have to look into that for
But
you.
thank
but
you.
It's slightly different on the
Yeah.
86. Sorry about that. Any questions?
still accept it, Chris, too.
I will still accept it. Yeah, thank you.
Thank you. Are you strict on rounding for anything?
On what was that
On
again?
rounding?
Routing? No,
Okay.
no. It's just WebAssign,
Okay, good,
honestly.
'cause,
I wish
like-
WebAssign wasn't such a bully about it. Sorry about that. Yeah, when it comes to quizzes and exams, as long as you're right there, I'm happy. Awesome, thanks.
I had a question. I guess
Sure.
it pertained to our homework. My son asked me this,
Mhm.
and he's doing a piecewise function. And you have x -1 comes down to this one, and then this one is 8x -1, and then 8x plus b.
Huh.
And that throws me off. I'm not sure. And it's
We
just
could
this,
Actually, yeah, I'm a little thrown off on this as well. This makes sense. This makes sense. Even the dots here make sense.
right? Because it's open, it's not included, but then
Yeah.
it's telling me ax plus b, and then they're included, so it means they're solid. But then depending on the slope and then the x where it intercepts on the y, I'm like,
Yeah, we need to have actual numbers here in order to plot that.
okay,
Geez, did the question show up that way?
Yeah.
With the X plus B?
yep. It's
I
just
know
like
you have
that,
some values for A, but
because I was playing with it in Desmos
Yeah.
and I put the slide rule on it. to
those are
set
all
it up.
just different lines, yeah.
Yeah, so I was like, okay, am I just trying to figure out a domain and range for this thing to go, you know, I mean,
They would have had to supply numbers there to really make it a fair question, because it's like they put a capital B times X inverse. You
Uh-huh.
can't plot this function without
right,
choosing a value for B. So there's something a little bit off about that middle row right there.
that's, I'm trying to get you,
You bring up this kind of deal and.
Yeah, what do they have for that?
Yeah,
A X plus B, find the values of A and B that make the function continuous. Oh, so you want your A to be such that this point goes down there and this point goes up there.
there, oh, so they touch, so
Yeah,
then it's, okay,
that is a weird question. I get it now.
okay,
So you're trying to find a linear function that goes from here to there, pretty much.
okay,
And then you're just solving that equation. You can pull the coordinates from the graph in those locations.
okay, and then that'll help me out figure out, okay, okay.
Yeah.
Got it, okay, thank you.
Yep, you bet.
Yeah. Oh,
Yeah.
Thanks.
And actually, I got a question on 2.7.
Sure.
It's just an algebra thing. Am I allowed to take each one down a degree like that when I'm doing it? Because to get -2/8⁵, the way I kind of saw it was I did direct substitution. I made it all 0 and then I took it down a degree there. But I was just wondering, can you also simplify it up here like that way?
So from here to here, this cancellation, you're just doing with the A's, right?
Mm-hmm.
So if you canceled all these A's, you would also have to cancel the A right here.
And then it would be there.
Oh, I see. I missed the part where you separate the fraction like this. Gotcha.
Mhm.
So if you're taking H to 0 and you separate it this way, yeah, you could cancel these three A's, then this A would cancel.
And then I would get -2 and then this whole thing goes to 0.
Yeah, that portion would go to 0 here.
Hmm.
You would get, if H is going to 0 on this one, let's see, -2A, A⁴, that's gone and that's gone. So you'd get a -2A over A⁴, which would simplify down to that.
And
Yeah,
that's where I simplify right there. Okay.
yeah,
Yeah, I'm good.
I think you're on the right track there.
Thank you.
Yep, you bet.
Is there any way you could do 13, like?
Sure.
With everybody on the board? Like, that would be really.
13 from what section?
7.
2.7, yeah, I'd be happy to. Is that one that has like a nasty fraction?
over T².
Gotcha.
Yeah.
You know, I actually have a harder one that I was gonna do on the end of the 2.8 notes, but
Is it like a fraction?
it's kind of like that one. Maybe it might be better to do both,
I
honestly.
cannot figure out the algebra behind it, so I just learned how to take the derivative of it.
Gotcha, yeah,
And I
we'll take a
solved
look
it
at
way.
that.
It was a lot easier to do that.
It can be sometimes on these. Some of these are gonna get just kind of out of control.
Yeah.
Forgot to actually put this on the thumb drive, but we can always just download it. That's another one. I think this one has been asked about in class as well. We didn't even start this one, so this will be an interesting one to take another look at.
Give us like the equation.
Yeah.
But you didn't quite solve it.
I just kind of left everyone to it at that point.